ShellBytes here. Today we're going to start building the ALU of our computer. So for those of you who don't know, ALU stands for Arithmetic Logic Unit. So basically we're just going to be doing adding today, because adding is cool. And it's the easiest thing that we're going to be working on. So I'm just going to be grabbing some basic supplies. What I generally do is I try and color code my builds. So I generally use red clay actually for logic circuits like this. Like easy logic circuits like XORs or ANDs, I would use green, but I actually use red for these more advanced logic gates. So I'm just going to grab some torches. I'm going to grab levers and buttons. But because I've got Project Red, I'm just going to take some cool fancy buttons because I can. Right, so let's start building. I know how to build an XOR gate just from memory because you use them so often. I would really suggest you just learn how to build them because they're really useful. So in case you're wondering what I'm doing, just go check out the previous video in which I was showing you how you build advanced logic gates such as this one. So that is the full adder, and to just check it's working we're going to stick some levers on here, and then this output should be on, and then we're going to put both on. That is off, and then we should get a carry, which we do, which is up here. Then if I enable the carry in, we still get carry out, and we also get that. That seems to be all working. Yeah, I'm happy with that design. I'm going to take these levers off. Now, if you haven't used WorldEdit before, you do /wand, and then you get your magic wand, which is actually a wooden axe. So snazzy, right? And then you basically left-click somewhere, and you get a little green box pop up around it if you're using WorldEdit CUI, which I am. And then you right-click somewhere else, and it puts a blue box around that, and then got some cool stuff happening there. You can see what area you've selected. If you want to expand it, you do //expand, which I'm going to do here. You face in the direction you want it to go. You do //expand. I'm going to do 2 because I need it to go 2 extra blocks that way. I also need it to go 1 block this direction, so I can just do /expand 1. And then that encompasses my whole region. Oh wait, I need to do it downwards. What if I want to make sure that I can see it without having to look down? I can just do expand 1 down. So that's a brief tutorial on WorldEdit. Then you can do a rather nifty feature, /stack. And it's going to be an 8-bit computer, so we're going to stack 7 because we want 7 extra copies. It's /cell for clear selection. Now this is the adding circuit. Seems quite big actually, but trust me, compared to the rest of the elements in our computer, this is going to be just about the smallest thing we create. Probably about the simplest as well. Could have just copied and pasted the levers with the things, but I didn't for some reason. Oh well. Now, if we test this out, we can see we will get an answer in binary, with this being bit 1 and that being bit 8. As in, like, that will hold the highest digit value and this will hold the lowest digit value. So, if we do something really simple, like if I just flick all of these ones on the left on, then we should get an output of all 1s. And then, to check that the ripple carry works, I'm going to flick this bit, and then it should all flicker all the way over across, and we should get loads of 0s and then a 1 on this carry out, which is right here. So that all works. I'm just going to unflick these levers. So now, this is all addition and all of that, but what if we want subtraction as well? Well, fret not, because it's actually pretty simple. We're going to go grab some green clay, because actually, you know what? Lime will look better. Yeah, there we go. And the way we do subtraction is to do A minus B, that's actually the same as doing not A plus B. And that is really useful because that basically means that we can take this and we can build a NOT gate, and that's why we learned about the vertical NOT gate over here, so that we can build it standing up like that, and then we can leave B alone but just not A, and then we can just NOT the answer. Okay, so I'm just going to clear that selection. I've saved it out as a schematic, so that means that if I skim load one wide XOR, I just copied it from the previous worlds, so I can just paste over there. Oh, that's in the wrong direction. Oh no, it's removed all of our build. / undo. Unfortunately, with WorldEdit, it does remove redstone, which is rather annoying. So I'm just going to put this redstone torch back, and that is all of the damage it's done, isn't it? Yeah, that works. That's fine. So I'm going to rotate my clipboard 180 degrees. And then, if I paste it, it goes the right way. So I'm just going to undo that. And then I'm going to stand on this block, paste. And then, in fact, we are going to move this whole contraption one block that way. Because we don't need this extra block at the end. So I'm just going to move one like that. Just deselect it. And then, there we go. There's our NOT. Not a NOT. What am I talking about? It's an XOR. So, what we want to do though is we want to convert it all into lime wool. So I'm going to replace iron, which has the ID of 42. I know I'm using 1.7.10, but I just remember 42 because it is the answer. And then it's 1595, so I can just do replace 42. It's just quicker to type than iron block with 1595. Then that's replaced it all, and I can see that this is an XOR because I know that they are green coloured in all of my circuits. So I'm going to stick levers on here. And why is this showing that value? This right here, that was our error. For some reason the torch hadn't carried over, so that now works properly as an XOR. And you may be wondering, why are we using an XOR? Because you told us that it's a NOT gate that we're using. We're doing not A, we're doing not A, not B. Sorry, not A plus B. And that's obviously not what I've just built. So, what am I doing? The answer is that I am actually using an XOR because we want this to be not only an addition circuit but a subtraction circuit at the same time. And we can do that because if you look at the truth table, you can see that if the bottom input is nothing, then the first input flows by unimpeded. But if the bottom input is on, then the top input is knotted. And that means that this bottom input is basically, are we subtracting? And the top input is whatever your input is. So I'm going to go copy this. I'm going to paste it right at the end over here. In fact, we might need to move that slightly. Put some redstone dust there. And this can flow directly into that. And that should work as a conditional subtraction. So I will tile this, and the way I'm going to do that is I'm just going to position 1, position 2, same old, it's all WorldEdit stuff. Then, because we're going to be tiling it like this, I'm going to expand 3, stack 7. And then that means that we have got this design tiled across forever. And I'm going to do that over the other side, of course. I'm going to take this. And I'm going to do that. Expand 3, stack 7, cell. Now, we are going to then create a bus. Now, buses are going to be in blue, but it's going to be light blue. You know what? I'm going to use dark blue because I think it might look nice. Yeah, I missed a couple of spots, right? I'll just fill that in. Now, as you'll probably be able to see, the signal strength is not going to go all the way to the end. So, I'm going to place in a redstone repeater, and then that'll be fine. And obviously, to make sure that it goes properly there, I'm going to take that, repeat the signal into the circuit as well. Now, obviously, we're going to have to do the same thing over here, and they have to be repeated into this circuit. So, I'm going to tile it this time. I'm going to use the tile feature of WorldEdit to my advantage. Stack, I meant, not tile. What am I on about? So again, it's going to be repeated into the circuit. And of course there's some extra wire on the end that we don't need. So what we're now going to do is we're just going to connect these up. Just a little bit of wire, just trailing over here. And of course it doesn't reach. The bane of making computers in Minecraft, me when I'm making computers in Minecraft, is that exact thing. Right, so we've got our outputs. These are our outputs, by the way. These things here. We view it that direction. So you can see our output is just a ton of zeros. And obviously, if we're subtracting, that shouldn't change anything. That should still leave us a whole bunch of zeros. Now I'm going to turn that off. So we're going to be adding. So we're just going to test that that still works. Obviously, we still need our levers on here to input. So I'm just going to input some sort of random number. Actually, it's not going to be random. I'm going to do a calculated sum. I'm going to do 20. I'm going to do 20 minus 6. Let's say. So 20 is 16 and 4, like that. And 6 is 4 and 2. So 20 plus 6. 20 plus 6 is 26. Which, of course, is 2 plus 8 plus 16. And then when we enable subtraction, we should get 20 minus 6, which is 14. And yes, there we go. We have it. And subtraction now works in our machine. So adding is sort of like the backbone, you could say, of a computer, because it is such a relatively simple operation on a computer. But we've now got it. So we've got addition and also subtraction now working. So that is a major leap forward in designing that computer. So I will see you next time, where we will be carrying on with making that ALU.